Have you ever looked up at the sky and thought, why is the sky blue and not green, purple, or pink? If air is colorless, then how does it make the sky blue? And here's a fun one. Why is the ocean blue, even though water itself has no color? Science has some mind-blowing answers to these questions. And today we're going to break it all down in a simple way. But first, let's start with an interesting fact. Did you know that on some planets, the sky isn't even blue? For example, on Mars, the sky often appears red, and on a moon of Saturn called Titan, the sky has an orange haze. So, if blue isn't the default color for every planet, then why is Earth's sky blue? Let's dive in. Understanding light. Before we understand why the sky is blue, we need to understand light itself. You see, sunlight may look white to us, but it's actually made up of 7 different colors, just like a rainbow. Ever seen what happens when light passes through a prism? It splits into different colors: red, orange, yellow, green, blue, indigo, and violet. But here's something interesting. Each of these colors has a different wavelength. Red light has the longest wavelength. Blue and violet light have the shortest wavelengths. This is super important because it explains why we see blue more than any other color in the sky. How light scatters. So, what happens when sunlight reaches Earth? It doesn't just pass straight through the air like a laser beam. Instead, it bumps into tiny particles in our atmosphere, mainly oxygen and nitrogen molecules. And here's the cool part. When light hits these tiny molecules, it scatters in all directions. This is called Rayleigh scattering, named after the scientist Lord Rayleigh who discovered it. Now, remember how we said that blue and violet light have the shortest wavelengths? Shorter wavelengths get scattered the most. So technically, violet light should scatter more than blue. But then, why don't we see a violet sky? Why do we see blue and not violet? You might be wondering, if violet light scatters even more than blue, then why doesn't the sky look violet instead of blue? That's a great question. The answer lies in how our eyes work and how the atmosphere interacts with sunlight. Our eyes see blue better than violet. Our eyes have special color-detecting cells called cones. These cones help us see different colors. But here's the interesting part. Our cones are much better at detecting blue light than violet light. Even though both blue and violet light are scattered in the sky, our eyes naturally focus more on blue because they are more sensitive to it. This means that even if violet light is there, our brains don't recognize it as much as blue. So, we end up seeing the sky as blue. The ozone layer blocks some violet light. Another reason we don't see a violet sky is because of Earth's ozone layer. The ozone layer is a special part of our atmosphere that absorbs harmful ultraviolet UV rays from the sun. But it also absorbs some violet light. Since a lot of violet light is absorbed before it even reaches our eyes, there's less violet light left to scatter and make the sky look violet. So, why is the sky blue? Because of these 2 reasons, our eyes being more sensitive to blue, and the ozone layer absorbing violet light. The blue light becomes the most visible color in the sky. That's why, when we look up, we see a beautiful blue sky, instead of a violet one. So, next time you see a clear blue sky, you'll know that it's actually a mix of blue and violet light. But your eyes and the ozone layer make sure that blue is what stands out the most. Why the sky changes colors. Have you ever noticed that the sky isn't always blue? At sunrise and sunset, it often turns red, orange, pink, or even purple. But why does this happen? The answer lies in how light travels through the atmosphere at different times of the day. The sun's position changes everything. During the middle of the day, the sun is high in the sky, and its light travels a shorter distance to reach us. This means that blue light is scattered the most, making the sky look bright blue. But at sunrise and sunset, the sun is lower on the horizon. This means that its light has to travel through much more atmosphere before reaching our eyes. The thicker the atmosphere the light passes through, the more scattering happens. This means that more blue light gets scattered away before it even reaches our eyes. So, what's left? The longer wavelengths, red, orange, and yellow. That's why sunsets and sunrises are often fiery and colorful. And the more pollution, dust, or smoke in the air, the more intense the red and orange colors can become. That's why places with wildfires or volcanic eruptions sometimes have incredibly deep red sunsets. Why is the ocean blue? Now that we know why the sky is blue, let's talk about something related. Why is the ocean blue? Many people believe that the ocean looks blue because it reflects the sky. While that's partly true, it's not the full reason. Water actually absorbs colors like red and yellow, but reflects blue and green light back to us. That's why the deeper the water, the bluer it looks, because it's absorbing even more of the red and yellow wavelengths. And in shallow areas, where light can reflect off the sand, water can look green or even turquoise. Pretty cool, right? Skies on other planets, different colors, everywhere. We know that Earth's sky is blue because of how light from the sun scatters in our atmosphere. But what if we traveled to other planets? Would the sky still be blue? The answer is no. Different planets have different atmospheres, made up of different gases and particles, which change the way light behaves. This means that the sky can look completely different depending on where you are in the universe. The moon. A black sky. The moon has no atmosphere, which means there's nothing to scatter sunlight. Without scattering, the sky remains pitch black, even in the middle of the day. Mars. A red sky. Mars has a thin, dusty atmosphere. The tiny dust particles scatter red light instead of blue, making the sky look red or orange during the day. But interestingly, Mars has blue sunsets. Titan. An orange haze. Titan, Saturn's moon, has a thick atmosphere full of methane and other gases. These gases create a dense orange haze, making the sky look foggy and orange all the time. Neptune. A deep blue sky. Neptune's sky is deep blue, but not for the same reason as Earth's. It contains methane gas, which absorbs red light and reflects blue, giving it a rich, dark blue color. Could a sky be green or pink? Yes. If a planet had different gases in its air or a different kind of sun, the sky could be green, yellow, or even purple. Scientists believe that exoplanets, planets outside our solar system, might have skies in colors we've never seen before. So while Earth's sky is blue, space is full of planets where the sky could be black, red, orange, or deep blue, and maybe even pink or green. So, now you know the science behind the blue sky. It all comes down to sunlight, scattering, and wavelengths. Short wavelength blue light scatters more, making the sky blue. At sunrise and sunset, blue light gets scattered away, leaving red and orange hues. Other planets have different skies due to their unique atmospheres. Next time you look up at the sky, you'll see it in a whole new way. If you found this video interesting, don't forget to like and subscribe for more awesome science facts. Thanks for watching.